date, we look up into the sky. We bring you exclusive footage from eclipses worldwide. We take our mobile observatory to where the action happens. Hi, Stefan.
Hi, Anna.
We collaborate with experts and observatories across the globe to bring you the best view of celestial events.
And we ordered the devil's horn just for you.
Now, we have to say thank you very much for your images tonight.
We explain how and show why it all happens while answering your questions during our live broadcast events.
That is a meteor.
Find your home and even more details on time and day. And subscribe to join us next time.
Good evening from timeanddate.com. I'm Anna Buckle. This is Graham Jones, and we're live in Leon, Spain for a total solar eclipse. And boy, are we excited. This is the first total solar eclipse since April 2024. So that's 28 months since the last one on Earth. And first totality on mainland Europe in 27 years. This is a sunset eclipse here in Spain, so we're sitting, the sun's already quite low in the sky, so we're sitting here under a tent for now because it is hot. We have 3 teams out from Time and Date. We've got one team here in Leon, that's Renate Molenhus and Jeremy Kraus. They're manning the telescopes here in Leon. We've got Stefan Thorsen, our chief eclipse chaser. He's in Mallorca, in Palma de Mallorca in Spain. He's got 2 telescopes going there. And then we've got Ada Opperhau in Stavanger, Norway for our deep eclipse in Norway. 85% eclipse there.
Yeah, and we have an amazing lineup of collaborators across the Northern Hemisphere.
Yes.
So yeah, just to pull back and look at the big picture of this eclipse. This is a solar eclipse across a large part of the Northern Hemisphere today. So it's a partial solar eclipse across much of Canada and the United States. It's a very deep partial eclipse across large parts of Europe, up to 80 or 90% across many places in Europe. And there is a thin strip running across the map known as the path of totality. And that's where today the moon will completely cover the sun and produce a total solar eclipse. And that path of totality is running through Greenland, through Iceland, and it's just reaching us here in Spain just before the sun sets. And we have partners across the Northern Hemisphere today. We'll be talking much more about them later on, but we have telescopes on the ground in Canada, in the United States, in Norway, in Germany, in the UK, and in Italy. So yeah, we are going to be bringing lots of views of this eclipse. Anna, we also have a wonderful partner in Iceland.
Yep.
So this is Sævar Helgi Bragason in Reykjavik in Iceland. He has been doing an amazing job in Iceland, helping everybody get ready for this eclipse. He was hoping to give us telescope images of totality in Iceland today, but the weather is just completely cloudy there. We always knew that Iceland was going to be a challenge in terms of cloud. And we're just really sorry for everybody who's traveled to Iceland for this eclipse. It does look like thick clouds across Iceland. That is the big disappointing weather news today. The good news is that across much of the rest of Europe, it's clear skies. And for everybody who's come to Spain to watch totality, it's generally clear skies across Spain. So good news there, very bad news for Iceland.
Yes.
Before we go any further, Anna, you do have an important safety message. course, these eclipses are amazing events for people to enjoy. But every time there's a big solar eclipse, sadly, there are always stories the next day of people going to hospitals and eye doctors because they have damaged their eyes looking at the sun. So, Anna, the message is to be very serious about eye safety.
Very serious indeed. Now, always during the partial solar eclipse, partial stages of a solar eclipse, you have to protect your eyes with proper sun filters or eclipse glasses like these. At no time during a partial phase of an eclipse can you take your eclipse glasses off. Share them around. Look around and see other people's reactions. You don't need to stare at the sun for hours and hours on end. You could put them on and you can see the moon slowly eating away at the sun. So there's lots of fun to do without staring right at the sun. And we also have some housekeeping, Graham.
Yes, we do. As you can see, we've got a lot happening on the screen here at the moment. So the eclipse hasn't started in Spain yet, but in our main picture, that's coming from Time and Date's Stefan Thorsen in Palma de Mallorca. We can see he's got a beautiful image of the sun. That's on our main screen. On the right-hand side of the screen, we have a smaller sun there from León in Spain. That's where we are, right here. Above that, we have a sun from Genoa in Italy. In northern Italy, we're working again with the Rigi Observatory. It's a very difficult eclipse to observe in Genoa because it really is happening very, very close to sunset. But Walter Riva at the Rigi Observatory, he's come up with a fantastic observation point for this. He's teamed up with Primo Canale, and they are at the top of a big building in downtown Genoa on a kind of a rooftop terrace known as the Terrazza Colombo. And they have a lovely view towards the western horizon and sunset. So that is our picture in the top right of the screen there. Meanwhile, Anna, on the left of the screen, we have our timeline.
We do. And our timeline shows where the eclipse is happening. So we're moving towards eclipse start in Iceland there. So it takes us through Spain, through Iceland again, and through Spain again. And yes, we would have wanted to have all the locations on there, but that would be a very crowded list indeed. So these are guiding times, but it'll show you, it'll show when totality happens in Spain and in Iceland. So that's pretty good. We've got it there on the side. And then below us, we have our trusty UTC clock that connects to the time there on the timeline. So we're all looking at this at the same time, depending on our time zone.
Yeah. So 1639 UTC right now. Our timeline goes all the way through until about 1930 UTC. Anna, that means we're going to be here for the next 3 hours watching this eclipse play out across different countries across the Northern Hemisphere. So keep watching us on timeanddate.com. Don't go anywhere. We're going to be back in about 10 minutes. And Anna, you are going to be having a chat with one of the people operating our telescopes here in León in northern Spain. That's Renata Moland-Hoos. And you're going to be having a chat with her about the science behind eclipses.
Yep. So we're going to be replacing Graham with Renata, and he will be coming back. Just relax. But Renata will be here for the next segment. And make sure to check timeanddate.com. We've got more information about the eclipse, about our partners there. So it's a good place to start and have a look at what we're doing. And we will be back with Renata soon. Welcome back to timeanddate.com, and we're here for a total solar eclipse, and we're just getting started. And I'm here with Dr. Renate Meulenhuis. She's an astrophysicist at timeanddate.com, and she has been manning the telescopes that are just outside the picture over here. There's still cloudy in Iceland. We can see here from the timeline that the eclipse has started in Iceland. If they're lucky, they might see a little break in the clouds. They might see the moon eating away at the sun. Let's have our fingers crossed that they can see something there. But here in Lyon, we're still waiting for first contact. We're looking at Jeremy Krause's big, beautiful sun there in the middle of the screen. We've also got Palma in Spain on the right-hand corner there, and Stavanger, Norway, there right below. All our feeds up, and it's quite an occasion. We usually have a lot of bad weather. So in about 40 minutes, first contact here in Lyon. But while we're waiting, we're going to talk to Renate about the magic of eclipses when it comes to science, and also just the awe that we feel when we're near an eclipse. So finally, we're here. We arrived on Sunday. It's been a busy few days, whew, especially in almost 40 degrees heat. That's 100 degrees Fahrenheit. It's been very hot for people and for equipment. And how has it been getting ready for this eclipse, Renate?
Yeah, so as you say, it's been quite intense. Of course, we started getting ready long before we actually traveled out here. We've been testing in the office and packing and making sure everything's in order. And then we came down here and started testing a lot. And of course, as you mentioned, our main problem has been the heat, both for us people, but also for our equipment. So the sun is the star of the show, but it's also making things a little bit difficult.
She's quite a diva.
Yes.
She likes to be the star. So we keep being asked what a solar eclipse is and why it happens. And we have an astrophysicist here that can explain it to us.
Yeah, well, simply put, a solar eclipse happens when the sun, the moon, the earth align so that the moon comes in front of the sun in the sky. And this solar eclipse here is special. It's a total solar eclipse. That means that from some places on Earth, you will see the moon completely cover the sun in the sky. And what happens then is that the darkest part of the moon's shadow lands on Earth and travels across a narrow path on the Earth's surface. And the people standing in that shadow, they get to see totality.
Just like we are.
Yes, just like we are.
Just like we are. And why are they so special for us humans, but also scientists?
Well, this is what you mentioned in the beginning. It's a little bit of where the magic and the science is combined. So you have that wonderful feeling of experiencing something special when you look at it. It's not something you see every day, especially for a total solar eclipse. You have the animals behaving differently, temperature dropping, things like that. But also it's a real possibility for science and experiments and data to be gathered. So that's really exciting. There's people gearing up to do real science experiments now, like NASA. They want to try and follow the moon's shadow to observe the corona, the sun's outer atmosphere. They want to send up balloons to study how everything affects Earth's atmosphere. So there's a lot of stuff going on.
Oh, it sounds like a lot of fun as well. And this is your first totality. I'm excited for you. What are you looking forward to?
Well, if everything is in order with the equipment, hopefully I'll be very busy during totality. But if not, then I can just stand back, enjoy, and watch it. I'm really looking forward to seeing the corona with my own eyes and also seeing how the animals behave and how they react to this happening.
Yeah, from my experience, the birds start flapping, the dogs start barking, so there's a lot of things that can happen. So we're finally super excited to finally be sitting here, and there's a lot more to come over the next 2 hours or so. Be sure to look at timeanddate.com. There you can find our news feed with updates on this eclipse and pictures and a lot more. So we're getting super excited. We're going to be here for almost 3 hours, so we will see you back here soon. You're watching a total solar eclipse here on timeanddate.com, and we have first contact Instagram in Norway, and I have shivers. I am so excited. Look at that. Oh, a little bit of artifacts there, but that is all part of live streaming eclipses, and we're getting super excited about first contact here in Leon. I have my eclipse glasses ready. First contact here will be in about 24 minutes.
That's right. Looking at the timeline on the left of the screen, well, we can see that the eclipse in Spain starts at 1730 UTC. That's when the eclipse starts in the very northern part of Spain. But more or less the whole of Spain, to within a few minutes, is running on very similar times for this eclipse. The eclipse is starting first in northern Spain, and then it's moving south down through Spain. So it'll be a couple of minutes after 1730 UTC when we see first contact here in Leon. Meanwhile, further north in Europe, definitely from our time and date observatory at our HQ in Stavanger, Norway, we can see the moon starting to take a bite out of the sun. And this is what people across Europe, if they have clear skies, are going to be able to enjoy this evening. That bite of the sun is going to get bigger and bigger and bigger until across many areas of Europe, we're going to have 80%, 90% of the sun covered by the moon. All that will be left will be a thin crescent sun.
Yeah.
Anna, we also saw earlier in the corner of the screen, we saw some images from St. John in Canada. The eclipse is underway there as well. We saw that there was a small bite being taken out of the sun in St. John. This is in eastern Canada. Our collaborator in Canada is Chris Kerwin. He does all kinds of wonderful outreach in eastern Canada. He has a Facebook page, Astronomy by the Bay. He is struggling a bit with clouds.
Yeah, we can
there
see
in St. John. So his feed is sort of coming in and out there on the side of the screen because it's not perfect weather there. It is a very cloudy part of Canada, but we definitely saw first contact from St. John. And
there you go.
Okay.
Speaking of the sun,
right? The clouds, as we speak, the clouds part, and there we see a bite coming out of the sun from Canada as well. So things have started here. We can also see on our timeline that the eclipse has also started in Iceland. That's the first marker on our timeline. Just a reminder that we do have clouds in Iceland. So unfortunately, it really looks like we're going to not be able to bring you any images from Iceland today because it's just thick cloud everywhere there. That's been the main disappointment with the weather so far.
We've been getting some really sad messages from our partner Seva Helgi Borgason there in Iceland, and he said it's been a really rough day because this has been leading up to this for many years of his life, and that's the horrible thing about eclipses is that if it's clouded out, it's clouded out.
Yeah. Mima, and as we've been talking, we can see that bite that the moon has made into the sun in Stavanger. I mean, that's grown as we've been talking. Maximum eclipse in Stavanger is coming up at 17:59 UTC. So there's still another 50 minutes where the moon is going to be eating away at the sun in Stavanger in Norway. Maximum eclipse there is going to be 85%. So 85% of the sun's disk will be covered by the moon.
And in Stavanger, we've been run down with messages. I've had so many messages about eclipse glasses that they are sold out, and so we have been putting out eclipse glasses for everyone to pick up at our office in HQ there. We're very happy to oblige, and they've been sharing them around. So I've been getting messages from my friends that are watching the eclipse right now. So excited that our hometown can see it as well.
Yeah, absolutely. So just to recap what we're looking at here, in Stavanger, Norway, at the time and date HQ, we're on our way to an 85% partial eclipse. At the top right of the screen, that's us here, Leon, in northern Spain. We're still waiting for first contact, still waiting for the eclipse to start. And St. John, Canada. Yes, the eclipse is underway there as well. Maximum eclipse in St. John, 17:55. So around the same time as Stavanger, but not nearly as deep. It is only a 29% partial eclipse in St. John. So about a third of the sun's disk will be covered by the moon.
So don't go away. We've still got first contact in Leon coming up, and go and check timeanddate.com for more information about the eclipse, about our partners, about the deepness of the eclipse where you are. Whatever you're looking for, you can find it there, and we will be back with you soon.
sun influences everything we experience on Earth. Influences everything we experience on Earth. To experience this. Earth is so perfectly positioned to experience this.
Totality hits.
This amazing phenomenon that is so rare throughout the universe. This is a
great time to learn more about our own star and how it affects our daily lives. There's no other feeling like it. It's insane. There's no other feeling like it. It's
Everybody should be
insane.
watching. Everybody should be watching.
Welcome to NASA's live coverage of the 2026 Goddard Space Flight Center. And over the next hour or so, we'll be tracking the eclipse as it races across the North Atlantic and Europe. As it races across the North Atlantic and when the moon moves between the sun and Earth and completely blocks the face of the sun, casting a temporary shadow on Earth. People located within the moon shadow, also known as the path of totality, will experience a total solar totality. The sky will darken briefly as if it were dawn or dusk. The sky will darken briefly as if it were people in the path of totality will see the corona. People in the path of totality will see the corona. Hidden by the sun's outer atmosphere, which is normally hidden by the bright face of the sun. Will sweep across Greenland, Iceland, northern Russia, Spain, and a small corner of Portugal. Northern Russia, Spain, many other areas in the northern hemisphere are already. Many other areas in the northern hemisphere are already, including much of Canada and parts of the northern U.S. Including much of Canada and parts of the northern U.S. of the eclipse path, such as mainland Europe and Africa. The eclipse will occur mainland Europe and Africa, creating a rare opportunity to see a sunset eclipse. Over the next couple of hours, we'll be bringing you live feeds from telescopes across Europe, and hopefully views of totality in Iceland and Spain. And hopefully views of totality in Iceland and Spain. Thank you so much to our partners, Time and Exploratory, for these views. During today's show, we'll be joined by experts to learn why today's show we'll be joined by experts to learn why celestial events like these ones are important to study, document, reminder on that experience. When watching a partial solar eclipse, you must always use the right partial solar eclipse. You can use safe solar viewing glasses like these ones. You can use safe solar viewing glasses like these ones, handheld solar viewer like this, or a safe handheld solar viewer like this. Or you can use sunglasses, no matter how dark, will not work, sunglasses and are not safe for viewing the sun. Will not work, be sure to and are not safe for viewing the sun. Now, so let's head over to my colleague Ernie Wright, who can tell us more about where the action is happening today. Who can tell us more about where the action is happening today.
I'm standing in front of the map that I made for the eclipse that we're going to experience today. We're looking down at the North Pole here, and the red stripe is the path of totality. The red stripe those are the locations that will experience totality today. Those are the locations that will experience totality today. As we animate this, you can also see the much broader penumbra shadow. You can also see the much broader penumbra shadow. That's where the partial shadow. That's where totality is happening. Inside that little oval. That's where totality is happening. Over the east coast of Greenland. The west passes over the east coast of Greenland, the west coast of Iceland, said, and they'll experience Spain. Whereas Joyce said, within an hour of sunset, so they should have lots of opportunities for really beautiful photographs. Have lots of opportunities for really beautiful photographs. And that umbra disappears, as the eclipse West Africa will also get an opportunity to see a partial eclipse. Also get an opportunity to see a partial eclipse. Is that penumbra shadow? As we zoom up and look at Iceland and Spain. And look at Iceland in that southwest corner of Iceland. Is here in that southwest corner of Iceland. We're kind of crossing our fingers for that because it's a little bit cloudy shadow is traveling over 2,000 miles an hour. Umbra shadow is traveling over 2,000 miles an hour and crosses the North Atlantic path. And then it runs into Spain here, where we expect more than 15 million people where we expect more than eclipse. 15 million people on the beach in Mallorca right before sunset. Some of them on the beach in Mallorca right before sunset, so they should get some really beautiful photographs. Now, the situation in the U.S. is going to look like this. In the U.S., that yellow line is going to look like this. Southern limit of the partial eclipse. Is the southern south of that line. Partial eclipse. You're not going to see an eclipse today. South of that but line, if you're north and east of that line, today. But if you're north and east of that line, the partial eclipse. Starting to see the partial eclipse. 2.5 hours for that partial shadow to pass all the way across the United States. Partial shadow to pass all the way across the United States. Totality. You don't have to run out there at the exact moment. You don't have to run out there at the exact moment. Some places will have a partial eclipse that lasts for some places will have a partial eclipse that lasts just an hour. Almost 2.5 hours. So this is the situation right now. Just an hour. Montana, so this is the situation right now. Montana shadow is passing out of North Dakota. The shadow is passing out of Wisconsin, Michigan. But you're Minnesota, in it. The Northeast is also in it. And for folks in the Mid-Atlantic, you'll be in it soon enough. And for folks in the Mid-Atlantic, you'll be inside to look at your eclipse that's happening right now. To look at your we want to show you a short video right now about how to observe this eclipse safely. We want to show you a short video about how to observe this eclipse safely.
If you'd like to find and explore the animated eclipse maps yourself, like the ones Ernie was referencing, safety instructions the ones Ernie about today's eclipse, safety instructions and much more about today's eclipse, head to science.nasa.gov/eclipses. So next, I'd like to introduce our first guest here in the studio. So next, I'd like to introduce our first guest here in NASA's heliophysicist. We have Dr. Kelly Corrick, who is one of NASA's heliophysicists, who studies the sun, and she's also studied the sun's corona in great depth. And she's also studied the sun's corona in great depth. It's great to be here. Thank you so much for helping us kick off today's coverage. It's great to be here. We see eclipses on Earth. So let's talk about why we don't always see eclipses on Earth. We've got this awesome model here called an Ori. Talk about their orbits and why we don't see it every month. Talk about their orbits and why we don't see it every month.
The moon and the Earth. Here we have the sun, as we move, the moon and the Earth. See that the moon is not exactly on the moon is not exactly that we have with the sun. So the Earth can view the sun pretty well, but when we get it to about here, we can see that sometimes maybe a little further here, we can see it lines up maybe a little further so that we're able to have that eclipse, and that's when we have that eclipse, and 5 degrees off, and that's when ends up not having an eclipse. So that 5 degrees off ends up not having an eclipse.
And so today's eclipse will travel across Europe. And so today's eclipse will travel across Europe for the first time. Can you tell me why does that region not experience eclipses? Can you tell me why does that region not experience that makes eclipses as often?
Right. So this eclipse is unique because of the fact that it's near sunset. It's unique because of the fact that it is near sunset. It's also the location, and doesn't get as many simply as to the location, and any place on Earth between the time you get eclipses. So there's a lot of ocean on the Earth that we get eclipses. So there's a lot of ocean on the Earth that we just don't. It just doesn't go over land very quickly. Plus with the angle, it tends to move very quickly. And again, it's super special being near sunset. So being able to see a sunsetting near sunset. So it's going to be able to see a sunsetting being eclipsed, it's going to be really awesome photos. Seasons. Can you talk a bit about that? I've also heard of eclipse seasons. Can you talk a bit about that? Happens like this, that lineup means that you're going to see happens like this, that lineup, or either a partial going to see the solar eclipse, or either a partial eclipse about 2 weeks later. So about 2 weeks will be eclipse about 2 weeks later. Orientation where the sun, the Earth is actually casting the shadow on the sun, and having Earth is actually casting the shadow on the moon and having a lunar eclipse.
And I know Europe is going to have another eclipse happening. And I know Europe is going to have another eclipse, which seems to be a lucky year for that region.
Yeah, definitely lucky, and it's going to be a wonderful eclipse. Yeah, definitely lucky, and it's going to be a wonderful eclipse. It's going to be 6 minutes and 28 seconds. So it's going to be 6 minutes and scientific 28 seconds. So it's a very long investigation. Great for scientific scientific
eclipses can occur somewhere on Earth.
And so
roughly every 18 months somewhere on Earth.
So why is
roughly
it that NASA
every 18 months to study solar eclipses?
So why is it that NASA continues to study
every
eclipse is a little bit different. The sun changes as because every eclipse is a little bit different. The sun changes as 11 year cycle. The Earth and changes the area of the Earth that it covers is different. So we make sure that we study it each time. Covers is different.
Fantastic. Thank you so much, Kelly.
Each time.
So fantastic. Thank you so much, Kelly. We'll be joined by other NASA experts like Dr. Kelly. We'll be joined by other NASA experts like Dr. Kelly that you have about solar eclipses, the science we're doing, and that you have about solar eclipses, the science we're doing, and all you can ask your questions in the chat on YouTube, Facebook. You can ask your questions in the chat on YouTube, Facebook, NASA, wherever you're watching. Instagram, or tag at NASA wherever you're watching. You today. We also have questions we want to ask you today. Instagram stories. So if you want to head over and take a look at the poll we've got for Instagram stories, you can take a look at the poll we've got for you. You can participate and answer those questions. Before we go on, I just want to point out that you may have noticed a clock counting down in the upper left corner of today's show. Counting down in the upper left corner of today's show. Displayed over the course of the next hour. Different countdown clocks displayed over the course of the next hour. That will let you know how close we are in the telescope views. We have an Iceland and Spain in the telescope views. We have an Iceland and Spain where we hope our telescope partners will be able to capture the best views of the sun, will be able to capture the best views of the sun, being totally in Reykjavik, Iceland at 1:48 in Reykjavik, Iceland at 1:48 p.m. Local time, and that will last 5:48 p.m. local time, and that will last. And then we're going to set our sights to Leon, Spain for totality there at 2:28 Leon, Spain for totality there at 2:28 p.m. Eastern time, and the eclipse there will be about 2 minutes time. And the eclipse there will be about 2 minutes long. There's a lot of science taking place during those fleeting moments of totality in Iceland. And we have experiments on the ground today in Iceland. And we have experiments on the ground. And in the view looking at right now, there's a camera that will be capturing looking at right now. There's a camera that will be capturing the view of the sun's corona when totality hits in Iceland. The planes are going to be chasing the moon's shadow for as long as they can. They're going to be studying the sun's corona where the skies will hopefully be clear up there. They're going to be studying the sun's corona where the skies will hopefully be clear up there. About an hour ago, and then we're going to be talking to the science team live from Iceland. We're going to be talking to the science team live from Iceland. Before we do that, let's learn more about what it's like to be a NASA pilot. Let's learn more about what it's like to be a NASA pilot in those eclipse experiments.
For most people, a total solar eclipse lasts just a few minutes. But NASA's pilots find a way to make it last longer. But NASA's pilots find a way to make it last longer by trying to outrun
the truth is, it's actually chasing us. We get out in front of it. The truth is, it's actually chasing us. Once we're in totality, we get out in front of it, let it overtake us. Once we're in totality, then we'll advance the throttles to max and try to stay in totality for as long as we can.
Making that happen, scientists calculate exactly where the airplane needs to be. Scientists calculate exactly where the airplane needs to be. We do a lot of missions where being in the right point in time and space. We do a lot of missions where being in the right point in time and space are critical. The WB-57 aircraft on Eclipse Day, the WB-57 aircraft climbs more than 50,000 feet into the stratosphere. Clouds, dust, and water vapor obscure the view. Clouds, dust, and water vapor obscure the view.
Provides a really clear shot of the sun. Provides a really clear shot of the sun. Have confidence that the data that they're seeing is on the sun. Have confidence that the data that they're seeing is on the sun rather than distortions from the atmosphere.
It engulfs the aircraft. When the moon's shadow
weird. Right where you're at is dark,
but
everywhere you see it's weird. Right where you're at is dark. Temperature in the cockpit everywhere you see is very twilight, and the temperature in the cockpit drops, so it's
the pilot keeps the aircraft on course. While the sensor operator keeps the aircraft on course, capturing every second of data. Fine-tunes the cameras, capturing every second of data.
It's very high pressure because of course there's no do-overs. very high pressure because, of course, there's no do-overs. You only get one opportunity to spot all these instruments trained on the right spot.
One of nature's most spectacular events. It's a chance to witness one of nature's most spectacular events.
I'm sitting in the best seat in the house. It's pretty exciting. I'm sitting in the best seat in the house. It's pretty exciting.
Wow, what a job they have today.
For this eclipse, the WB-57 aircraft has a camera on the nose of the plane that will be capturing images of the plane that will be capturing images of the sun's corona. Principal investigator Amir Kaspi, who is chatting with us live from Kaspi Airport in Iceland. Hi Amir, thank you so much for joining us today. Hi Amir, thank you so much for joining us today. So firstly, how are you feeling right now? And can you tell us how are you feeling right now? And can you tell us what experiment you're doing today?
Well, feelings are mixed today because as you can see behind me, the sky is not very great for those of us here on the ground. The sky is not very great for those of us here on the ground. That's now cruising at 50,000 feet. We have an airplane that's now cruising at 50,000 feet above sea level that's preparing to observe the eclipse in just about 14 minutes. Imaging the solar corona. We are going to be imaging an instrument that has 4 cameras on board, an instrument that has 4 cameras on board, observations ranging from visible light through observations ranging from visible light mid-wave infrared, which we often refer to as the mid-wave infrared, which we often refer to as the corona, and to make new observations of the corona and learn all about coronal structure and dynamics.
What is it about the corona, the sun's outer atmosphere that we're still trying to better understand?
Well, you know, we've known for about 100 years now that the corona is incredibly hot. It is millions of degrees hot, even though the solar surface is only a few thousand degrees. Even though the solar surface is only a few thousand degrees. And we're still trying to understand exactly that energy up. The corona's magnetic solar surface into the corona to heat it to from the solar surface into the corona. Our observations today will open new discovery space with wavelengths today will open new discovery space with wavelengths that are very rarely physics models to better understand how that physics models to better understand how that corona is heated. The structures of we'll also be looking or material the structures lower down that's kind of suspended in the corona. Lower down that's kind of suspended in the corona. Especially in trying to understand wavelengths where we don't have a lot of observation, infrared wavelengths where we don't have a lot of observation to understand. Of course, all of this will also space weather that affect us. The sources of space weather that affect us.
That was in Genoa. That was in Genoa. So in Italy, they've had just one during the Savannah, like
what did you learn from those hoaxes? And are you making any
and here in Leon, Spain, you can see the sun is barely intact, but we're very quickly
our first
coming
attempt at this kind of observation, our first attempt at this kind of observation, measuring in the midwave and measuring in the midwave observations and new measurements that I think open observations and new measurements that open future experiments to try to better understand some future experiments to try to better understand what the emissions of the sun.
That's right. So just to recap, the moon's shadow is moving across Spain from the northern coast down across to the eastern coast, and then the eclipse is ending out in the Mediterranean. So Mallorca will be really the final place to see totality today. The eclipse here in Leon started at 17:32 UTC. So any moment now, we should be able to see the eclipse starting on our feed from here in Leon. We should be able to see that in the first tiny flash coming out of the sun. So we'll keep our eyes on the
there is a bit of lag, and we have to say that when we're sending our there is always a 2024 delay, so we're just waiting for it to start finding it from 2 years ago.
This data with new scientific
measurements
we're
still in the shade.
new scientific measurements much faster than
I know the plane is about to capture the eclipse. I know
Yep, it has now started. At the bottom right of the sun, we can now see that very imperceptible first flash. Just the moments after first contact, that's when the edge of the moon just starts to eat away at the sun, and there we are. The eclipse is very much underway in Leon, here in Spain. Totality in Leon is coming up in about an then to our partners for this beautiful telescope. We're about 10 minutes away from totality in Reykjavik, Iceland. 10 minutes away from totality in telescope view. Over the next hour or so,
the telescope valley at the moment,
will be getting more and more until at 1828 UTC. We will have 1 minute and 45 seconds of totality where the sun disappears from the sky.
That is what we want. So before totality comes, we have a few minutes to
hole
show
in the sky,
different
and we
we have
see the solar corona, the sun's outer atmosphere.
Iceland is a great place for astronaut training.
And you might see me a little bit distracted because I'm looking out at the field that we're sitting in, and the locals are coming in their patches, they've got umbrellas, they're coming up and saying hola, and we've enlisted a local to help us shoo them a little bit away because we're trying to tell you guys all about the eclipse and showing them how to read the glasses and the trace as well. So we're not alone for enjoying the eclipse with
Absolutely. Now, Anna, we should also mention we have something new on the screen as well. Just above us, we have our live eclipse map. And this shows us where totality is happening right now. So we're looking at a map of the northern hemisphere. There we've got Canada on the left, we've got Greenland in the middle, and then we've got Europe on the right-hand side. The shaded area there shows where a partial solar eclipse is visible today. And there's that dark strip running down the middle of the map. That is the path of totality. That is the very narrow strip that you have to be on if you want to see a total solar eclipse where the moon completely covers the sun today. And in the middle of the map, we have that bright red dot. That is where totality is happening right now. So right now, in Greenland, that's where that red dot is. So that is where totality is happening right at this moment. This is a live map, so that red dot is moving south. It's moving towards Iceland. Totality in Iceland starts quite soon, at 1743 UTC. That's what it's showing on our timeline on the left-hand side of the screen. That's when that red dot is going to arrive at Iceland. And then it's going to continue moving south. It's racing towards us in Spain. And totality will be arriving here in Spain in around about 15 minutes from now. The moon's shadow, it is moving across the globe at a really high speed. In the bottom right corner of our map, we have the speed that the moon's shadow is traveling across the globe. It's 3,500 kilometers an hour, which is 2,200 miles per hour. So totality is racing towards us at high speed. The weather here continues to be great across much of Spain. We've got lovely clear skies here. So yeah, totality is on its way. Just again to say that we do have telescopes in Iceland, but we also have completely thick clouds. So unfortunately, no images of totality.
But for those that are in Iceland, we will be able to come up on air Wednesday, especially in April.
That's right. Even if you can't enjoy seeing the sun disappear, you will notice the effects of it because it will be dark. So in Reykjavik, in the Icelandic capital, there's 1 minute of totality. So even though it's cloudy, everybody there is going to notice as totality approaches, the light levels dropping off until you get that much more darkness effect for 1 minute during totality, because up above now, the sun has disappeared.
So first contact hasn't happened in Spain. It should be happening in the north right now. We might be able to get some images up from them now if they're listening to me in the HQ in Stavanger. So first contact happening very soon, right now as well. So I think that's
yeah, just great. So yeah, as 1738 was first contact in Mallorca. So yeah, everything is just happening a few minutes after each place as the moon's shadow moves across.
So we're going to put our eclipse glasses on. We're going to continue looking up at the sky here in Leon. And I hope you can see the eclipse are checking exactly what they're describing. Up next, we're going to put some Jeremy Krause about an amazing feat for looking at
well, that's incredible. Artemis 2 is just launched. Can you tell me how you're preparing for that mission?
Yeah, so Artemis 3 is a different type of mission. We're not going to be going to the moon. We're different type of mission. We're not going to be going to the moon. And so this will give us an opportunity to test our human landing systems, which will be the spacecraft that we take down to the surface of the moon. And so we'll work to hopefully dock with one or both of the human landing systems with one or both of the human landing systems to do a lot of science at Earth, because this will be to do a lot of science at Earth, because this will be a new,
what an exciting few milestones to look forward to. What an exciting thank you so much for joining us today.
Thank you so much for having me.
Well, Marie, thank you so much for joining us today.
Thank you so much for having me.
Take a look at these maps that we're showing you right now. Take a look at these maps that we're showing you right now. You can see that it's close to reaching Iceland. We're about 5 minutes away from totality in Reykjavik. We're about 5 minutes away from totality in Reykjavik. You can see that we have about 45 minutes left of totality. You can see that we have about 45 minutes left. So these are views from Vielabada in Spain. So these are views from Vielabada in Spain that we're seeing right now. You'll see if we switch back to the shadow, you'll see that the moon slow as it's traveling across down towards Spain. But it's traveling across down towards Spain. But it's actually traveling at over 2,000 These maps were made by my colleague Annie Wright. These maps were made by my colleague Annie Wright. He used various NASA satellite data. If you want to view and download them yourselves, you can visit science.nasa.gov/eclipses. You can visit science.nasa.gov. So now let's welcome back NASA heliophysicist Dr. Kelly Corrick. NASA heliophysicist Dr. Kelly Corrick.
I'm excited for everyone.
How are you feeling about today's
eclipse?
Clouds are
I'm excited for everyone, and I know those clouds are a little worrying in Iceland, but also joyful to see the balloons that are going to be launched, as well as see the balloons that are going to be launched, as well as
yes, and I'm sure the NASA pilots must be excited as well in the plane. Yes, and I'm sure the NASA pilots must be excited as well in the plane.
Yes, exactly. It's a great view.
So here we're seeing a live view from the WB-57 aircraft sensor right now. From the WB-57 aircraft sensor right now. Then also away from seeing the moon shadow hit Earth, and also chasing the eclipse. We haven't actually seen the we haven't actually knows that they will be capturing the Coronia, and we'll know that they will be capturing images. And on the right hand side we're seeing a partial eclipse. And on the right hand side we're seeing really exciting. So we have places from Norway, which is really exciting. That will be able to witness a partial solar eclipse. That will be many people here. That will be many people amazing that will be able to experience this amazing celestial event. Let's see how many we're about. Let's see how many. 6 minutes away from totality in Iceland. 6 minutes away from totality in Iceland. What do we expect to see right before totality?
Right, so right before totality,
we're in that partial eclipse that's going deeper and deeper.
We're in that partial eclipse that's going deeper and deeper.
Things go dark.
So even if there are clouds, you start to see get a little bit darker. So even if there are clouds, it's going to drop too, because again, you blocked out some of the sunlight, so you're going to drop too, because again, you blocked out some of the sunlight, so you're going to get cooler. There's really wind that'll pick up. So the eclipses aren't really full body experiences. You might also notice that animals react as well. It's not just humans. You might also notice that animals react as well. It's not just humans that they might start to pretend that it's nighttime, or realize it's nighttime, start to pretend that it's nighttime, and this is realize it's nighttime, and start to kind of nest, and this is very unique for that part of the world, because right now they are going to be a little shocked by this, and so they are going to be a little shocked by this, even if you don't get to see the beautiful corona. Even if you
I'm thinking about everyone on the ground in Iceland right now. Yeah, I'm thinking about everyone on the ground in Iceland right now. They may be seeing how does the climate shift when an eclipse happens? Can you tell me how does the climate shift shift when an eclipse happens? Because I've heard that the weather can change drastically.
In 2017, I was in South Carolina, and in 2017, I was in South Carolina, and there were thunderstorms just around the sun, and was able to actually just around the sun, and was able to actually that was my first total solar eclipse, and see my first total. That was my first total solar eclipse. So there is hope by that change in day night, that eclipse that's coming by that change in day night, that eclipse that's coming through. So we're hoping that some of the winds and some of that changes could change things
right now on screen a live right now on screen and that's because the telescope views in Iceland, and that's because the telescope views in Iceland. As Kelly mentioned, I'm hoping that the clouds will part. As Kelly mentioned, I'm hoping that the clouds will part and the weather will change for them. Anything can happen at this point, right?
We'll talk about it a little later. And also, we'll talk about it a little later. The atmosphere of the Earth is still being affected, even if there is cloud cover, and that helps us with predicting weather models. So it's not just about the coronal science, which is something that I'm very passionate about, but it is also about understanding our planet and how it interacts. But it is also about understanding our planet and how it interacts that we're getting from it. And you see, we're starting that we're getting something in the WB57. It's getting very something in the WB57. It's getting very close. That's they were going in there.
Okay, so everyone who's watching right now,
wow.
Okay, so everyone who's watching right now, you will see the live views from the WB57 aircraft. That's where the NASA pilots are chasing the that's where the NASA pilots are chasing the eclipse from the skies. So Kelly, can you tell me why? What are the benefits of observing up there at 50,000 feet?
Wow. Okay, so observing up there at 50,000 feet. Wow. Okay, so look at these. These are great. 50,000 feet. So they're above the clouds, and we're able to again allow it to overtake us, and we're able to again seconds of totality to overtake us. So they get a few more seconds of totality. You saw that beautiful pink filament, something that Amir talked about. Is that filament that is the material that Amir talked about? Is that filament that can actually create space weather and affect our power grids here on Earth? It can affect our GPS. So if you ever on Earth, it can affect our GPS. So if you ever use your maps to get anywhere, to understand that's something that we can. It also affects our astronauts, our dear astronauts, so making sure that they're okay. Our dear astronauts, so making sure that they're okay. One of the reasons why we have the WB57 to study, and one of the reasons why we have the WB57. It's a little hard to see, but in the words on the right-hand side, you see that pink filament now, which is on the right-hand side, WB57 feed, which is on the right-hand side. The NVIS area now kind of right in the center. The NVIS area now kind of right in the center. And so this is amazing data, and it might not look as crisp. And so this is amazing data, and it might not look as crisp down here. We're used to, we're used to 4K data down here. But this is telling us very specifically about part of the data. So it's like taking very specifically about part of the data. So it's like taking really getting the information about the iron or the oxygen or the specific composition of what that's made of. And if we know what it's made of, we can do what that's made of. And if we know what it's made of, we can do more.
So we're about like a minute and a half away from totality in Iceland. So we're about like a minute and a half away from totality. We have a minute and a half for the clouds to part. And so we have a minute and a half for the clouds to part. So the sun view that you're seeing here, that is not of Iceland, but that is of the partial eclipse in Spain. But that is of the partial eclipse. Iceland is still being covered with clouds, but Iceland is still being covered with clouds, but totality will hit them in about a airplane, the WB57 aircraft. And luckily, getting clear airplane, the WB57 aircraft from the skies. So we're going to be seeing the eclipse from the camera on the nose. So we're going to be seeing what the camera on the nose of the plane will be seeing. So exciting! In roughly 1 minute.
Definitely.
Which is so exciting.
And you are starting to see some of the definitely. And you are starting to see some of the so those little would be a diamond ring effect things that you're seeing. So those little this is when happens when light passes through the valleys. When happens when light passes through the valleys of the moon. It has those craters, and there's that diamond ring effect. It has those craters, and there's that diamond ring effect. And that's when you still should have your glasses on. And when that ends, and that's when you still should have your glasses on. And when that ends, this is an experiment, right? And so this is part of the reason why we're seeing kind of, right? And so this is part of the reason why we're seeing kind of in and out. The arrows or the crosshairs go real time how science happens. Is that we are trying to make sure to make adjustments and make sure we're getting an image. Make sure to make adjustments.
So we are 7 seconds down to totality in Iceland. This is really exciting. We're getting a shot of the ballooning experiment. This is really exciting. We're getting a shot of the ballooning experiment as well. This is the nationwide eclipse ballooning project. For the past 24 hours leading up to this eclipse. Which is so exciting. I can see that they're getting really excited as well. It's so exciting. I can see that they're getting really excited as well. Despite the data, even though they can't see the eclipse. Is that right?
Exactly. They can still collect data. They are still experiencing a little bit of that darkness. They are still experiencing a little bit of that darkness. It's obviously darker see the corona itself, and a little bit looks like sunset around the 360 and a little bit looks like sunset around the 360 degree where it'll be very vivid. Hopefully we'll see this imagery there.
Yeah, so it looks like totality has hit Iceland. Yeah, so it looks like totality has hit Iceland, which is so exciting. You can see that by darkness here. So that is so exciting. I can see them smiling. So that is so exciting. I can see them smiling. Oh my goodness.
So why do we see it? Because there is light on either side. It's just simply blocking out in that specific shadow. It's just simply blocking out in that specific shadow. One location, but the rest of the earth is still illuminated. So location, but the rest of the earth is still illuminated. So images of the sky and the airplane. There's images of the sky.
So we have experiments happening in the air and on the ground in Iceland, which is so exciting. On the ground in Iceland, and then what we're seeing now is the
you are back and watching this solar eclipse across the northern hemisphere.
Iceland, they are experiencing totality right now. We've experienced Iceland, they are experiencing
on our
totality right
screen
now. We've
at the moment, in the top right-hand corner, we have pictures from
and it's really interesting looking at the sun. There are some
southern
and it's really interesting
Norway.
looking at the sun.
Our pictures there are coming from our partners, the Agda Astronomy Forum in southern Norway. They've got a beautiful present sun. Maximum eclipse in Christian is in about 10 minutes from now at 1800 UTC. And at maximum eclipse, 84% of the sun will be covered by the moon. So that's what we're seeing.
We want to take every opportunity we can.
In the main image on the screen, this is what's happening right here in Leon, in northern Spain. The eclipse is well underway. Totality will be starting at 1828 UTC. So we've got a beautiful flash here. This telescope that we're getting this image from is being operated by our very own Jeremy Krause, who is right here. And Jeremy, you've come to tell us a little bit about some of the struggles and some of the joy so I mean, you've been preparing for this for quite a few weeks back at our HQ in Savannah. How has that all gone?
How much can we actually
compared to years we have to wait for a sunny day.
It's really about having all of the observations, right? It's really about having all of the observations, right? Because we definitely need that totality of the surface of the sun that we can
and we do a little bit of a run through
for that space that we can see where that surface
yeah, absolutely. So we don't expect that many sunny days just about this time of the year, unfortunately. And then when we do, a nice sunny day, possibly somewhere around
both ways of getting observations.
More contrast with
both ways of getting observations.
Yeah, how has it been for you during testing here in Leon?
That's a good question.
Yeah, well, we chose this location because of
the great
trying to be understood
something up. If you imagine temporarily stop heating something up right when things get cold, they tend to sink, and so the air is
and we did
cold, they tend to sink, and so the air creates wind, and you start
quite incredible actually. It's been
so the weather changes, you start to just turn down. So the weather changes due to just turning off
all sorts of little gremlins have been coming out of both of us and our equipment. It's been quite an interesting struggle of problem solving and debugging.
Yeah. So the equipment has
to do research training of Iceland terrain.
Can you tell us a little bit about
and we definitely addressed both, right? There were we definitely addressed both, right? There are great things in the Arctic area for especially in the Arctic area, Iceland, and then we had a team balloons that we sent to Iceland, and then we had a team. So
there's a lot of little
failure points, I guess you would say. So keep your questions coming in. We'll be answering so much. So keep your questions
telescope, cameras, cables to the telescope.
I also mentioned that we had the head over to viewers as well.
So it's been quite a struggle.
Yeah, but hey, the result is spectacular. It's a beautiful image here. Now you're working in our next door chat with Renata Molenfus, who Anna talked to earlier.
I'm going to
right that Renata's
so we have altitude, the International Space Station, an observation,
This is her
an observatory telescope room. It would be a tough choice between
that's such an interesting station or high altitude plane. They've got such a huge overview. It's great. She actually has a just a more general night sky.
Thank you. We're going to check back into those results.
So we're going to check back into those results. Really meant to be sitting in the baking hot sun of Northern Spain.
We have another NASA-funded experiment involving
we have
another NASA-funded experiment.
And what are some of the solutions to this heat?
Well, we've been putting on our MacGyver hat, and basically we've been doing everything we can, from pieces of string to cable ties, gaffer tape. So I've been using a reflective yoga mat chopped up into small little pieces and sacrificed to wrap around our equipment, towels, hanging over things. It's a little bit scruffy, but it's working and it's keeping our equipment cool. We've even using the ice packs on
data from balloons that go high up into the atmosphere.
Under the machines and wrapping. Doing our best to just regulate
that has mostly engineering students.
Wow, excellent. Jeremy, thank you very much for coming and having a chat. We should let you get back to looking after the equipment there. Just to recap, on the screen here we've got our feed from Stavanger, Norway, maximum eclipse in Stavanger, 1759, maximum eclipse in Stavanger, partial eclipse there. In the top right corner, images from Palma, Mallorca, that's on the path of totality, heading towards total solar eclipse. We are going to be back very shortly, so stick with us on timandate.com. Keep enjoying these images from around the world. Still to come, totality here in Spain. So we will be back very soon.
They measured stratosphere and atmospheric gravity waves in the air caused by the temporary cooling due to the drop in sunlight.
What excites me the most about this project, what excites me the most about this project is thinking about the experiences that the students have that they'll remember forever.
Talking to us live from Mosfos Bay in Iceland. Talking to us live from Mosfos Bay in Iceland. We have Jared and Tessa, who are part of the nationwide. Thank you so much for joining us. I know you just experienced the total eclipse. Thank you so much for joining us. I know you just experienced the total eclipse in Iceland. How was that for you?
It was awesome. I mean, it's definitely cloudy here, which is a shame. But I mean, it's definitely cloudy here, which is a shame. But we were indoors. We saw the lights dim. It was almost as if you were indoors, which is I've never been in the path of totality before, so I've never seen anything like that. I've never been in the path of totality before, so I've never seen anything like that.
Yeah, the winds totally stopped. It was windy, and then it just stopped. Totally stopped. It was windy, and then it just stopped all day, and then they just had the birds flying over us all day. It was a little eerie, kind of creepy.
Wow, that's amazing. I'm so glad that you could experience that, even though you know. That's amazing. I'm so glad that you could experience that, even though you know you had about what you've been doing. I see you've got balloons launching in the background. What are you doing? I see you've got balloons launching in the background. What are you measuring with the balloons in Iceland?
So we have balloons that are measuring a lot of different things, like temperature, pressure, that are measuring a lot of different things, wind direction, temperature, pressure, and this is supposed to gather the wind direction changes during the eclipse. And this is supposed to gather the normally during the day changes during the eclipse. Air rises until it hits less dense air, and this is called the boundary layer. Air rises until it hits less dense air, and this is called the boundary layer. This air stops, but during nighttime when the sun is down, this air stops, that's exactly the same thing that happens during the eclipse. So that's exactly the same thing that happens during the eclipse, and we're using these radio changes to boundary layer collapse and then the atmospheric changes. And boundary layer collapse not just because it's in the path of totality. We're in Iceland not just because it's in the path of totality, shorter nights make it also different boundary latitude, and it's shorter nights make it opportunity to be able to study that under. So it's been a really cool opportunity to be able to study that under the eclipse under
college
this
students
unique
right
conditions.
now. How long have you been
So you're
part
both
of the
college
project,
students
and
right
what made you
now.
want to
How long
join
have
the
you been
project? Part of the project, and what made you want to join the project?
So we started this project at the beginning of June. We've been working with our teams, respective teams, and working with our teams, respective teams, and then my team made up of students from across Idaho, my team made up of students from across Idaho. We've been meeting once a week, doing balloon launches, preparing. We've been meeting once a week, doing balloon launches, preparing, and me into it was my ballooning club that we have at the University of Idaho. Ballooning club that we have. We all just, we love the science, we love the teamwork, we love the science, we love the teamwork, team building. It's been a lot of fun. And
that's great. And so, do you have any tips for students who are thinking about joining? And so, do you have any tips for students who are thinking about joining?
Yeah. So my biggest tip would be to get involved. My biggest tip would be to get involved. Through my club. That was how I learned about this project. Professor through my club came to us and was like, "Hey, there's this really cool opportunity." Came to us and was like, "Hey, there's this really cool opportunity. Put an application in." And then also just, you know what, if you have. And then internship opportunities, and you see those, just put an application in. Opportunities, and you never know, just put an application in. You could get. You never know what.
And then also, I would say, if you have a class that you're really interested in, also I would say, if you have a class that you're really interested in, need any help on the research, because see if they have need any help on the research, because to apply your classroom knowledge to real life scenarios, to apply your classroom knowledge to real life scenarios, which you don't usually get in the classroom. Like going outside the country for the first time, like I'm doing right now. Like so, going outside the country for the first time, like I'm doing right now.
Well, best of luck. I know you're launching continuously after the eclipse. I know you're launching. So thank you so much for joining me, Tessa and Jared. So thank you so much for joining me, Tessa and Jared. So the nationwide eclipse ballooning project are also launching nationwide eclipse ballooning project are also, and I can't wait to see Spain as well as Iceland, and I can't wait to see the observations. The moon shadow is heading towards Spain right now, and we're roughly half an hour away from Spain right now, and we're roughly half an hour away from totality. The moon shadow is roughly 182 miles wide at its maximum width, and it's traveling at over 2,000 miles per hour, and it's traveling at over 2,000 miles per hour. Views as well in the bottom corner in Leon, Spain, in the bottom corner you can see the little bites that the moon has taken out of the sun, and we can't wait to see taken out of the sun. They looks like they have clear skies. We can't wait to see totality there. They looks like they have clear skies, which is awesome. And so, if you are watching the solar eclipse from the ground, if you are watching the solar eclipse from the ground, viewing glasses remember or eclipse to wear safe solar viewing glasses or eclipse glasses. The only time you can take them off is during totality. The only time you can take them off is during totality. If you're watching the partial eclipse in the United States, if you're watching the partial eclipse in the United States, you can wear eclipse glasses the entire time. Head to if you want to learn more about eclipse safety, head to science.nasa.gov/eclipses. So total solar eclipses give us a chance to study the sun's corona in greater detail. Give us a chance to study the sun's corona in greater detail. Affects us here on Earth. About how it behaves and affects us here on Earth. The sun is highly dynamic and creates conditions in space called space weather that can affect conditions in space called space weather that can affect communication satellites from GPS systems and communication satellites on the ground, airplanes, and but in order to better understand it, we have a suite of spacecraft that are monitoring the sun. We have a suite of spacecraft that are monitoring the sun from different more about NASA's space weather program. So let's learn more about NASA's space weather program.
Across our planet, billions of people depend on the invisible networks that connect us to space. On the invisible networks that every day those networks are at the mercy. Every day those networks are at the mercy of the temperamental sun unleashes across our solar system. And the space weather that it unleashes. That's why NASA's space weather program tracks solar storms from the moment they erupt, anticipating their impacts, modeling their paths, and leading the research that the world's industries rely on. The research that the world's industries NASA's rely on. Space weather research and modeling is driven by the needs of society and enables critical decision making of society that equips pilots to reroute around high radiation that equips pilots to reroute around high radiation areas, to adjust GPS-based precision planting and to adjust GPS-based precision planting and harvesting to mitigate the impacts of potential surges. To mitigate the impacts for those exploring other worlds. NASA provides 24/7 space weather monitoring. NASA provides 24/7 space weather monitoring for Mars astronauts. Artemis crews who may be exposed to dangerous levels of radiation may be exposed to dangerous levels of radiation, whether you're a pilot or a passenger. A farmer, a pilot or a consumer, passenger, a power grid operator, a farmer or energy consumer, a satellite operator or energy user, a satellite controller or GPS user. Space weather impacts us all.
If you're just joining us, welcome to NASA's live coverage of today's total solar eclipse. 25 minutes away from hopefully seeing the first instance of totality in Spain. So stay tuned for that exciting moment. So stay tuned for that exciting moment. Is one of NASA's space weather analysts. Karina, thank you so much for joining me.
Thanks for having me.
Karina, thank you so much for joining me.
Thanks for having
monitoring the sun in real time. Can you talk a little bit about what you do? Real time.
Yes, of course.
Can you talk a little bit about what you do?
Yes, of course. So what we do is we basically observe, and then we document it. Analyze, and so what we're observing is usually those coronal mass ejections, or as I lovingly like to call them sunbursts. And we're measuring those, seeing where they go, and we're modeling them to see what NASA emissions or possible planets they impact, and then from there we're documenting it and notifying NASA emissions about potential documenting it and notifying NASA emissions.
And so we just learned a little bit about NASA's space weather program.
And so we just learned a little bit about NASA's space weather program.
Affect the everyday person?
How does monitoring space weather affect the everyday person? The everyday person is going to see it in terms of northern lights. The everyday person is going to see it in terms of northern lights. Some of that impact what we do also see is some of that impact to the GPS. You don't really know why, but that could possibly be a little wonky. You don't really know why, but that could possibly be. And then we may also see some impacts to agricultural folks who are using tractor precision farming. Agricultural folks who are using tractor precision farming.
We saw these huge solar storms. We saw these how that storm affected Earth, and if we had to mitigate any of these storm affected Earth, and if we had to mitigate any of these effects.
Yes, we did have to do some mitigation, but honestly my favorite part was seeing the northern lights. But honestly my favorite part was seeing the northern lights. And so 2024 is when I first got to see the northern lights that I took on my phone. And then you're seeing a picture that I took on my phone, which was absolutely incredible. And you can see a picture of the team that I worked with, and you can see a picture of the team that I worked with, the Heliocosmos Analysis Office, where we got to see it down here in Maryland, which is absolutely incredible. We got to see it down here in Maryland, which is
and so I know that you were also part of the team that monitored space weather. That you were also part of the team that monitored space weather when we flew astronauts around the Artemis 2 mission. What was that experience like? Around the moon?
Surreal.
What was that experience like?
It's very surreal to be staring safely at the sun via satellite imagery, but safely at the sun via satellite imagery, but not see it in person. Because I was working the overnights, but it was incredible. Because I was working the overnights, but it was incredible. And I loved if I were to do it, I'd want to be one of those astronauts. If I were to do it, I'd want to be.
Well, thank you so much for joining us, Karina. Absolutely. Well, thank you so much for joining us, Karina. Let's hear from NASA Administrator Jared Isaacman and Head of NASA Administrator Jared Isaacman and my colleague Jasmine Hopkins caught up with them a few days ago to talk about why this celestial event is so important and what the celestial event is so important about the sun and what the 2026 eclipse can teach us about the sun.
Today, I'm thrilled to talk all things eclipse with NASA Administrator Jared Isaacman, who's leading our vision NASA Administrator Jared Isaacman, who's leading our vision and Dr. Science and why eclipses from our Science Mission Directorate and Dr. Nikki Fox from our Science Mission Directorate will tell us an eclipse. Exactly is going on with the sun during an eclipse. Okay, fantastic. Our opening question is for both of you. Okay, fantastic. Our opening question is for both of you. Just a couple months ago, we wrapped up the historic Artemis 2 mission eclipse, and now we're on the cusp of in one word solar eclipse right now. Can you describe in one word how you're feeling right now?
Excited. Excited is the right word because when you saw that total solar eclipse, because when you saw that total solar eclipse spectacular, and nobody was ready for it. It was so spectacular. Even people who see total solar eclipses all the time, even people who see total solar eclipses all the time, the beauty. And so when you saw that, it just brought the beauty into such space, and the beauty of the science we do into such clarity.
I think NASA is one of the only places where we can see a solar eclipse from down here on Earth, and then from the other side of the moon.
Things that we study the sun all the time. It's one of our main things that we study in NASA science. We look at it from all different wavelengths, we look at it from all different vantage points to be able to predict come towards our planet because we want to make sure our astronauts are safe. Because just we want to make sure our astronauts are safe. The eclipse just gives us just a little bit opportunity to really study that sun just a little bit more to keep our astronauts safe. Make those big breakthroughs to keep our astronauts safe.
If you could witness a solar eclipse from anywhere on Earth, where would you
solar eclipse from anywhere on Earth, or would you choose having been that doesn't have clouds for the last eclipse? Having been clouded out go anywhere for the last eclipse, I will say I will go anywhere that there's no clouds.
Look, Iceland is where Spain, a lot of the observation locations in the Valley of the Kings. In Egypt, in the Valley of the Kings.
And that is going to be the longest total solar eclipse of the 21st century. It is over 6 minutes. Total solar eclipse of the 21st century. It is over 6 minutes. In somewhere ancient is particularly moving. In somewhere ancient is particularly
What's the one thing you want people to walk away understanding about why studying eclipses
Very much describe that magical event as a magical event. Describe that eclipse as a spark. And who knows how many people creates a spark. Imagine what's possible around the world and start contributing what's possible in adventure and start contributing in this great adventure that we're on.
Remember that Einstein confirmed his theory of relativity using an eclipse. His theory of relativity using an eclipse. Eclipses are very powerful. You see stars, you see constellations, you see planets that you don't normally see. You see stars, you see constellations. It kind of reminds you of our place in the universe. It kind of reminds you of our place in the universe.
Is there even new to learn so much about the sun?
There's always new stuff to learn about the sun. There's always new stuff to learn about the sun. But it's the only star we know right now. It is our star, but it's the only star we know right now that has the responsibility to continue to try and answer the question, and as we sort of continue to try and answer the question, understanding our relationship with our sun is so important. Understanding our relationship with our sun is so important to do that. Eclipses, it is honestly the only time that we can really observe some of the phenomena. It is honestly the only time that we can really observe some of the phenomena. Really looking at how the corona turns into the solar wind. Looking at how the corona turns into the solar wind. But we live in the atmosphere of the planet, so when you get these big events, they can cause havoc for technology here, and they can cause havoc for technology keeping our astronauts safe in space. So understanding our sun is more critical today than understanding our sun.
Thank you both so much for being here today. Really appreciate it.
Thank you.
Thank you both so much for being here today. Really appreciate it.
Thank you.
Thank you to our NASA Administrator, Jared Isaacman, and Head of NASA Science Administrator, Jared Isaacman, and Head of NASA Science right now, who is going to dive into our eclipse maps right now, and where the eclipse is heading next. And where the eclipse is heading next.
It's so exciting for me to watch this eclipse progress. It's so exciting for me to watch this eclipse progress. You really can't anticipate how you feel about them until you see them. So I'm standing in front of the eclipse map, and just I'm standing in front of the red stripe is the path of totality. This red stripe is the path of totality. Those are all the locations you're seeing experience totality. Partial shadow. You're seeing from the partial shadow. It has already crossed Alaska. It's over Canada. It has already crossed Alaska. Right now. It's over Canada. And that little oval is the umbra where totality is actually taking place. It has just passed by Iceland, and it has just passed by Iceland. Got to experience the secondary effects of an eclipse. People got to experience the secondary effects of an eclipse, where you get the brightness along the horizon. And the brightness along the horizon be over northern Spain, where we expect more than 15 million northern Spain watching. We expect more than 15 million people will be watching the eclipse. Partial eclipse in Western Africa. Partial eclipse so this is a close-up Western Africa. Reykjavik is here. So this is a close-up view. They unfortunately had clouds here, but the WB-57 was flying just above that. But the WB-57 was flying just above that. That if you're on the center line, you get the longest kind of the spot that if you're on the center line, you get the longest eclipse of 2 minutes, a few nights away from seeing totality. We're just a few minutes away, less than an hour before sunset. Spain. That should produce some really beautiful photographs, especially for folks some really beautiful photographs watching this over the mountains to the west. On the beach, watching this over the mountains to the west. This is an unusual eclipse. It's kind of weird. This is an unusual eclipse. One reason for that is one reason for that is total eclipse starts. This is the Timir Peninsula starts in northern Siberia. This is the Timir Peninsula, and because they're so far north, Siberia, that eclipse starts at midnight. Because they're so far north, they are that eclipse starts at Arctic Circle. So the sun is up 24 hours a day. So the sun is up 24 hours a day. The other kind of odd thing about it is, and then the other kind of odd thing about it is most eclipse paths, most totality paths, most eclipse paths, most totality paths But this one, because it's so close to the pole, and because this one, because it's so close to the poles, and because the orientation of the Earth, and the fact that it's starting in the north and going to the south, and then suddenly making starting in the north and going to the south into Spain. So we're looking forward to seeing into Spain. So total eclipse in Spain, where the weather looks great. Total eclipse in Spain, where the weather looks great.
Thank you so much, Annie. So we're about 15 minutes away from totality in Spain. Minutes away from totality in Spain. And I want to say thank you again to our partners, Time and Date, and I want to say thank you again to our partners, Time and Date, for providing these stunning telescope views for providing these stunning. This is really, really exciting. They have 15 minutes left. This is really, really exciting. They have 15 minutes left until the sun is completely obscured. Earth is not the only place you can experience a total solar eclipse. Earth is not the only place you can experience a total solar Space Station.
Welcome back to watching the Total Solar Station here on
several solar eclipses from
.com.
this very unique colleague Abby in Toronto.
So you can tell even from the light on our faces that it feels like sunset. And it is sunset, but it's way too soon for the light to be so dim as it is now. The light is feeling different. It's just got that kind of, I don't know, twilight feel to it, and it feels a bit wrong. There was some dogs barking earlier. People are gathering in the field overhead. There's dogs running around. They've got their pop-up chairs. They've got everything. They're so excited for the eclipse. And so you might hear them in the background because there's going to be some oohing and ahhing and excitement going on.
One of the big things is that around Earth, these particles can be affected that are around Earth, and those particles can be affected.
Getting so excited about this eclipse. We're looking at some gorgeous images there on the screen.
Yeah, so these are our two images, our two locations in Spain, where totality will be happening in about 15 minutes from now. The big picture is coming from Palma de Mallorca. We're seeing some lovely details on the sun. And I mean, that's just really showing us, Anna, that the sun is not just a bright yellow disk. There is a lot happening on the surface of the sun. There's these hugely intense magnetic fields at work. And so we get all of these
just reminds me of one of my mentors from graduate school. Just reminds me of one of my mentors from graduate school, Jerry Coyman. So I think if I could share it with you,
we can. We also had the Leon picture there in the top right. Castle in Germany. Maximum eclipse in Castle was about 4 minutes ago.
Your new home.
Thank you so much. It has just really appreciate you taking
Thank you, Abby. It's been wonderful speaking with everyone today. Thank you, Abby. It's been wonderful speaking with everyone today. So keep looking up and we'll be waving at you.
So this picture we're seeing here from Leon in Spain, the moon is eating away at the sun. It's causing that crescent shape of the sun. That crescent is going to get thinner
last report from Mission Control, Jessica.
until we just have
Jessica,
just like one of those new moons where you can just see that tiny sliver of a crescent. That's what's going to happen to the sun. Eventually, the crescent will shrink to just a single point of light. We can start to see the solar corona. And the combination of that bright point of light and this shimmery solar corona around the blackness of the moon, that gives us the effect of the diamond ring, this bright jewel of sunlight with this sort of shimmery ring around the moon. The diamond ring quickly disappears and turns into Bailey's beads. These are the very fine blobs of sunlight we can see before the sun gets completely covered. It's sun shining through valleys around the edge of the universe. And those are the final bits of sun we will see until the moon covers the sun completely. That's when totality begins. That's when it's okay to remove solar eclipse glasses and enjoy totality when we can see the solar corona, but it doesn't last long. So here in Leon, totality starts at 1828 UTC. We'll have 1 minute and 44 seconds of totality. The moon's shadow will just keep racing southwards towards Bailey's beads before any part of the sun is visible. And then the solar corona disappears.
Sometime after the show, NASA will also be releasing exclusive eclipse images from Spain as
well. So totality in Leon, 1828. Totality in Palma, New York, 1831. That's UTC. Just a reminder that local time in Spain, it's coming up to 8:30
some of the crowds there that we're seeing, you can see that they're the darkness is looming. It's not quite totality there yet, but they are almost there, which is awesome. So now I'm going to, I'm joined here by NASA's key physics director, Joe Wesley. Joe, how are you feeling about today's eclipse?
Oh, super excited. Super excited to see it and to share our science, NASA science across the world.
The telescope going.
So if you're watching from the ground and you don't have eclipse glasses, there are actually many ways to watch an eclipse.
Computer's been overheating, but the temperature has been going down.
So Joe, do you want to walk through some of those methods
we're hoping, with us? Yeah, so these are super cool. This is stuff that you've got at home and things that you can use to help you view an eclipse safely without your glasses.
So excited about that.
Just a standard colander, right? What you would have in your kitchen. Maybe clean some, berries or whatnot with it. And I'm going to demonstrate how you would use this to look indirectly at an eclipse.
Okay.
You're using the light of the sun as it would filter through this colander, and let's demonstrate together.
Okay, so
yeah, if you could hold that.
So do you need a piece of paper?
You don't need a piece of paper.
Okay.
You can just have it on the ground, something light that you could see.
Okay.
I've got a flashlight that's sort of demonstrating what an eclipse would look like. It's got a little piece of foam there that'll show. So let's shine our light. Let's do our sun, and then show it as it would hit the this colander. And what you can see there is these nice little crescent moon shapes, which are showing the eclipse on our on our example paper here. So that would usually be a bunch of circles, like if you took this out during regular daylight. Here in the US, you would see just a little sliver gone. Over in Spain, of course, they would see these beautiful little crescent moon shapes.
So you don't want to be looking through the colander, but you want the sun to be shining through it.
Absolutely.
Okay.
Right.
Gotcha.
You want to use this as your light filter for you. And the cool thing is you can use this, but you don't have to use this. There's lots of other possibilities. So you can actually take your hands, right, like this.
Okay.
Spread your fingers out.
Yep.
Hold them over top of each other. And you make little pinholes yourself when you do that.
Okay.
Right? And when you do that, you can actually see through and be able to see the eclipse in the same way, right? So that's a cool way to do it. And then on top of that, let's say you're taking a walk in the woods. Well, the leaves of the trees actually make these kind of pinholes all over for you as well. When they do that, you get this beautiful, constant crescent moons and everything everywhere. One of my favorite ways to see an eclipse.
Thank you so much, Joe. And so today's eclipse, August 12th, also lands on another special day. So on this day in 2018, NASA's Parker Solar Probe launched into space to study the sun's corona up close. Joe, can you tell us a little bit about that mission?
Yeah, what an incredible mission. This is humanity's opportunity to actually touch our star, right? We flew a mission, Parker Solar Probe. It's still up there, it's still operating, it's still taking great science, but it's flying within the corona, within what you see in the total solar eclipse, and taking direct measurements of that corona to help us understand how our sun works.
Amazing. So we have a lot of questions coming in from social media, and we have time for just one, Joe. So let's dig in. Kyle asks, it seems to be that there are a lot more solar eclipses happening the past few years. Did something change?
Nothing changed. The geometry of the sun, the moon, the earth is the same. But one of the cool things about our technological society today is you get to see many more of these things, whether it be because of social media, because of, people have access to cell phones, or just the accessibility of travel and being able to go to these different places. I'm personally really glad that people are hearing more and more about eclipses because it brings the greatness of NASA science home to all of you.
Thank you so much, Joe, for doing this demonstration and for being with us here today.
Thank you so much, Joy.
So now let's head back to the eclipse map where we're going to see the eclipse in real time. So as you can see in the bottom part of this video, the moon's shadow is just about to reach Spain. We're about 3 minutes out from totality hitting Spain. Leon, Spain is going to be experiencing totality, and it will be getting about 1 minute and about 44 seconds of totality, which is so, so exciting. The path is going to be hitting several other towns as well, such as Mallorca and Villalobado. And the view that we're seeing right now is of Leon, Spain. And even though totality hasn't occurred yet, you can see a tiny little prominence, on the one side. Okay, so remember to be safe when watching a solar eclipse. You have to be wearing safe solar viewing glasses or use an indirect viewing method when viewing when the moon hasn't completely covered the sun yet. You can only look at a total solar eclipse during totality when the moon is completely blocking the sun. So back in the studio, we have Kelly with us again. Kelly, what is it that makes this eclipse in Europe so, so special?
It really is so special because, again, this is almost at sunset. So we're experiencing something that's a little bit different, having it so low on the horizon. And look at those images there. You're seeing that darkness already coming in, those kind of sepia tones instead of the normal bright light or even the normal types of sunsets.
Wow, so we are 2 minutes away from totality in Spain. You can see the crowds in the bottom corner there, and this is the sun's view. Oh my goodness, so 2 minutes until totality, and we have a slither of the sun left. This is just amazing.
Yes, it's so beautiful. And like you were saying, there is that prominence there that we already see. So these are things that are very interesting and, again, can erupt in the space weather that we were talking about earlier. So this is a great view. And even with this, it's not complete darkness. That little bit of sun still lights it up so that we can see the crowd.
Wow. So we're about 1.5 minutes away. What should people expect to see moments before totality hits?
So what they should see is what we call the diamond ring effects, or the Bailey's bead. So these will be really bright lights, and it's from the last bits of sun coming through the moon's valleys. So that will come through, and we'll see that. And you still need your eclipse glasses or an indirect viewing method at that point in time. But then once that's done and you're in the path of totality, it's time to remove those glasses and see the corona with your own eyes.
Wow. And if you're on the ground, what other sensations will you be feeling?
It will definitely be getting colder. There might be a wind. You could, again, change in animal behavior, any wildlife that's around you, and really the sense of awe, as well as the 360-degree sunset all around the horizon. So just a few things to look for.
Wow, this is a stunning, stunning view. We have just a slither left, and this is the moon covering the sun's disk. And when totality occurs, that slither will disappear. We're about 30 seconds away now from totality in Spain. If you're on the ground and you have clear skies, we are so, so happy for you.
Yes, definitely.
Wow.
It's just beautiful, and again, probably feeling so much excitement, and sometimes you even feel a little fear, like I think was mentioned earlier, they felt it was eerie almost. It's an eerie light. It's not something that we're used to in the human experience, but here it goes. We're getting close to those Bailey's beads of the diamond ring effect, so those should be coming very shortly.
Wow. All right, totality is almost there. The slither is about to disappear.
Oh,
okay.
The little diamond ring.
Wow.
Yeah. All right.
Totality has hit Spain.
Yes.
Oh my goodness.
Lovely view.
What is the red mark that we're seeing on the image right now of the sun?
So the red mark is that filament. So it's a bunch of very hot material that has been hanging above the sun and just kind of hanging out there based on the magnetic fields of the sun that keeps it kind of in a little magnetic cage. Oh, look at that. That's a really nice view of the corona. You're seeing things that look like streaks coming out of this, and those are streamers. So that's the basis of the solar wind that we are bathed in constantly. The sun is constantly outflowing material, and so that's that constant stream, and then you see what could become a big chunk at some point in time in the pink filaments that you see there.
Wow. So we see that coming off of the sun. So this is the atmosphere of the sun's corona. Are those streaks that you just mentioned, are they coming towards Earth as well?
They are coming towards Earth. So they fill the entire solar system, or the heliosphere, which is actually all that the sun encompasses with that solar wind. So it's the entire solar system, so it definitely hits us here on Earth.
Wow.
And this is absolutely beautiful. Again, you're seeing a prominence also on both sides, really, and maybe even one up on the other corner.
Oh, wow, yeah.
So there's lots of, even though the sun is supposed to be towards a minimum of activity, which meaning you should see less of this, we're seeing more of it. And this is one of the important reasons why to keep studying these eclipses, is to see what is actually happening on our sun. When we think we know what's going on, it seems to change it up a little.
And what is it about these features that are so important to study?
It's important to study what they're made out of. Oh, and now we're back to the diamond ring, so we're coming back out of it already. It was always... Oh, wow. Yes, it happens so quickly, and once you see one, you definitely want to go back and see some more.
Wow. So totality has ended.
Yes.
In Villabado, Spain. Wow, so you're telling me that we also see the diamond ring and Bailey's beads at the end of the eclipse as well?
Yes, exactly. Wow. When you're going into or out of the eclipses.
Okay, so this is a view from Valora La Buena in Spain as well. They are seeing an eclipse right now. Eclipses happening in Spain are about a minute apart from one another in these telescope views. So they're seeing totality. So the red mark that we're seeing right now, is that another prominence?
Yes, those are prominences, that material that is suspended above the sun that's very, very hot. Again, it's interesting to us to know what they're made out of. There's normally filters, like here and on the airplanes as well, to tell us about whether that's some iron or whether that's carbon or oxygen or what exactly is those pink filaments made out of.
And you can see the moon is moving away from the sun right now. What is it that we're watching?
Yeah, Bailey's beads, and so these are the beads, and so now we're actually going out of totality again. So
wow, what a brief moment of totality. This is just amazing. They have had clear skies, and this is exactly what you want for a total solar eclipse. Yeah. Wow. This is Mallorca in Spain. Oh my goodness, this is stunning.
Wow, yeah.
Look at that corona. Why is it so much clearer? Why is the corona so much clearer during a total eclipse?
Yes, yeah. So it's so much clearer because you're taking away all the bright light from the face of the sun. The sun is very, very bright, so it's basically a million times different. And when you blot out that middle, you can see all the beautiful things that are going on behind it. And so, yeah, so this is the beautiful crescent moon that you're seeing. I think previously we were seeing those strikes of light. That's also closer to sunset there as you go more south in Spain. And already the light's returning, and they seem to be very excited in the crowd there.
Yeah.
It's such a great feeling to experience those eclipses, even though they were so short.
Wow. And experiencing a total solar eclipse, that is completely different to a partial eclipse.
It really is. And it took me, even as a heliophysicist, it took me a while for them to convince me that I should do it. And once I saw my first in 2017, I've seen multiple since, because it is a full body experience. It is very different than seeing just one bite out of the moon. The whole body experience and just the joy and awe and kind of your place in the world is so important to experience.
Absolutely. I'm for sure now an eclipse chaser. Well, that was an incredible solar eclipse. What a view. I am thrilled that their skies were completely clear, which means that we could see the sun's corona so clearly. And we could even see multiple prominences as well from the sun, which is a beautiful sight during an eclipse. So in a few minutes, we're going to be speaking with a NASA astronaut live from where they saw a total eclipse. But first, let's go back to the poll that we posed to you earlier on in the show. So, Kelly, I know that you had answered some of those questions as well. So let's take a look at what our viewers thought about those questions. Okay, so let's head to one of the poll questions. But while we're kind of like waiting to get that set up, let's continue looking at this beautiful partial eclipse now in Mallorca, Spain.
That's just gorgeous. That is just absolutely gorgeous in terms of that very little sliver. Again, this is towards sunset. So normally if you're looking at a sunset, especially over water, you're seeing that kind of orange ball, red ball go down, and then you have this beautiful eclipse to happen. These really are just going to be spectacular images.
Yes, absolutely. Okay, so let's head back to the poll answers. Our viewers, so the first question was, where would you rather watch an eclipse from? You said the International Space Station, yes. And our viewers would agree.
Yes, it'll be a party on the International Space Station.
I also wanted to be there too, so we're all going to be up there. The second question on the poll for everyone watching was, what would be your ideal eclipse watching soundtrack? And the options were cosmic lo-fi beats, dramatic space opera music, chill acoustic sky watching vibes, or just the sounds of nature and the crowds. And the winner was cosmic lo-fi beats.
Oh, all right. Yeah, that's a good soundtrack. I can see that.
Yeah. I voted for opera music, but
yeah, and I might be a little bit more sounds of nature, but you know, that's just me.
Okay. Well, anyway, thank you so much.
Thank you.
So, although totality is over, the partial eclipse will still be visible for the next hour or so. Remember to stay safe while watching the rest of the partial eclipse by wearing eclipse glasses or by using an indirect viewing method. And so if you want to learn more about eclipse safety, go to science.nasa.gov/eclipses. Okay, so next we have a very special guest calling into the show live. NASA astronaut Don Pettit just witnessed the total solar eclipse from Alcañiz, Spain. Don, can you hear me? How are you doing?
I can hear you loud and clear, and I'm standing out in
You're back with us on
Alcañiz,
timeanddate.com, just on the
just
other
in
side
awe
of totality
looking at
here
the totality
in Spain.
phase of
So,
this eclipse.
let's
Wow,
just
so how are you feeling? I know
recap
you just
what happened
finished
there.
watching the eclipse.
Right
How
now,
are you feeling
on the
right now?
screen,
What did you
we are
experience
looking
on the
at
ground?
a
What
crescent
did you
sun
hear?
in
Were you
Palma
surrounded
de
by
Mallorca
crowds at all?
and a crescent sun in Leon in
the
Spain.
sky
So
is
this is just now a few minutes
exceptionally
after
clear, and
totality
there's
happened.
hundreds of
The moon
people
is now
here, and
moving
that's part
off
of the eclipse.
face
It's not
of the
being off
sun,
by
and we're
yourself.
also
It's
heading
being
towards
with a
sunset.
group
The
of
moon,
people,
the moon and the sun are both getting really
people that
low
live in
in the
Alcañiz,
sky.
the group
We
of
have our map above us. For the last couple of hours, there's been a red dot on that showing us where totality is happening. That red dot has disappeared.
Amazing. So people
because
know you for
the
your
darkest part of the moon's shadow has now slid off the edge of the Earth. It was traveling at a really high speed.
Did you take any photos during this eclipse, or did you put your camera down for this one?
Into space.
Oh, no,
and so
what I do is the same thing for launches. You set a camera up on automatic,
partial
and
eclipse
you get
is
whatever
still
you
going,
get from the camera, and then you stand back.
What did we
and you
see
watch
on the
launch,
screen
or you watch the total
during
eclipse.
totality?
They're
Well, on
both
our
kind
feed
of in the
from
same
Leon, we
category
saw
in
that crescent
they
sun
only
getting
last
thinner and thinner,
a couple minutes in terms of
just
what you can
disappearing
see,
when we
and
got to
it's better
totality.
to view them through your
the
own two
ideal
eyes than
telescope
through the viewfinder
for
on
watching
a camera.
totality
Okay,
was
good tip from a
Renata's
NASA astronaut.
white light
So
telescope.
how did the experience
That's the one we've
watching
been
this from
talking
the
about
ground
earlier, the
compare
one
to
that's been
watching an eclipse from
overheating
space, which I know
and
you've
has
done a
been
few
having
times?
all these troubles in the
had
sun.
the opportunity
So
to
we
see
didn't have the
two,
ideal telescope there for
solar
catching
eclipses from space,
totality, but we certainly
and
saw
in space,
the sun
you look at the
disappear
shadow
and
projected
reappear
on Earth. You don't
on the
look
images
at
there.
the
We
sun
then switched
itself,
over to our
and the
feed
shadow
from
has all the
Mallorca,
detail
and we did
that the
see a
classic
beautiful
astronomers
totality
from
there
hundreds
with
of years
the
ago
solar
predicted.
corona
You
around
see
the
the
edge of the
umbra,
sun.
you see the penumbra,
But there's
you see
also
the shadow
a very
moving over
human
Earth,
factor
and it's
that,
a
of course, at
vantage
the
point
moment
from
of
space
totality,
that you
everybody
can't see
in
from
Mallorca
Earth.
had their
Wow.
mobile phones
So
out. Everybody
lucky.
was
And I know you've
taking
seen a lot
pictures.
of other
Everybody
beautiful
was
phenomena in
streaming
space, like the
video,
aurora
and the
airglow.
internet connection
What is it
from
that
there,
makes
as
watching
we
a
saw on the
total
screen,
eclipse special for you?
really suffered. So yeah, that was a very human explanation for that. It's just so many people in Mallorca were enjoying totality that they were just breaking the internet.
It's experiencing the
So that's what was
reaction of
happening
all
on the
people
screen.
you're watching it with.
Meanwhile, here in Leon, on the ground in Leon, the sun is coming back, the light levels are going up, the temperature is changing again. I've done all the talking so far here because Anna,
well, thank you so much, John. Any parting
you're
words?
in your post-totality phase.
Get out and watch an eclipse,
how was
whether
that
it's a total eclipse
on the ground
or a partial eclipse.
I had a big
They
cry.
happen. Lunar eclipses happen. Get
we
out
did stand
and
here
look up at the sky and think about what's going on and smile.
In the arm.
Thank you so much for joining us live from Spain. We're so grateful you could share
It's
your
really hard to
absolutely
describe other
amazing
than
solar
like a
eclipse
big black
experience with
hole
us.
in the sky surrounded by a beautiful,
you all
beautiful
take
halo,
care.
and it's of
Wow, Kelly, it's amazing
wings
to
of
hear someone
corona
as
that just
passionate and knowledgeable.
into, and it's just, if you get yourself to see a totality anytime in your life, do it, because it's so worth it. And the people here were wowing and clapping, and there were a few dogs barking, not so many birds flapping about as I expected. So but you really, like, the mood just completely changes, and I just, my heart is like in my throat and in my stomach at the same time at the moment, because it's just awe-inspiring, and it's part of just making you feel like a tiny human in this big universe, lining up to let the moon cover the sun like that. And I could waffle on about this for ages. You have to stop me, Graham.
Yeah, you're certainly right about it. There was a wonderful reaction here on the field just in front of us, in the village that we're in. Everybody, of course, came out for totality. And the reaction of everybody was absolutely amazing. It is we still have lots to come here.
We do.
On timeanddate.com.
I have to pull myself together.
we still have the second partial phase of the eclipse to enjoy. The sun is getting down closer and closer to the horizon. In Palma de Mallorca, the sunset comes there first. 1849 UTC is when the sun is setting in Palma. It comes a bit later here in Leon. We're just a bit further across on the globe. Sunset here is at 1928 UTC. So our plan is to follow the sun all the way down to the horizon for the next hour. So we still have a lot to enjoy. We're also hoping to talk to the person who's been running our telescopes there in Palma on the island of Mallorca. That's Stefan Thorsen, our chief eclipse chaser at Time and Date. So stick with us. Still plenty to come. We will be back soon, and we'll hopefully be talking to Stefan in Mallorca.
You're watching a total solar eclipse here on timeanddate.com, and the light's coming back. The moon's disk is moving off the sun again. And yeah, we're still got a little while before sunset, but in Palma de Mallorca, where Stefan Thorsen is, the sun has already gone down. And Stefan, you have a special surprise for us. Can you show us?
Hi, Anna and Graham. Now, we did have some problems with transmission or something of the eclipse, but fortunately we did record it. So we'll do a little attempt to just show it all again, the way at least we got it here. So we haven't practiced this, so this is a bit sort of maybe it doesn't work, but I will gonna start the recording of the eclipse we had in Palma now.
I'm just letting, yeah, that's it.
Okay, yeah, there's the diamond ring, which is quickly turning into Bailey's beads, and then totality is beginning now.
Oh, wow.
Yeah, and there is the solar corona around the edge of the moon, and on the left-hand side of the moon, it looks like we're seeing some big prominence there on the left-hand side of the moon. We can just see that sort of, it looks like that bit of the sun sort of erupting upwards. That's, we were talking earlier about all the magnetic activity that's happening on the sun. There is so much going on the surface of the sun, and we can see that sort of sticking out on the left side of the sun here. Wow, this is a beautiful minute and a half of totality to enjoy in replay.
In replay. So this is the recording of the totality in Palma de Mallorca. That's why we've removed our little live thing there. So we're not pretending that this is live. And Stefan, yeah, it's looking beautiful. And now it feels like a really long time. But when you're seeing it in real life, it is just like, it's over.
Yeah, when you think this is one of the few chances that solar physicists get to really study the solar corona, it's over so quickly. We're coming to the end. We're coming to the end already here. We're going to see the Bailey's beads again, these little blobs of sunlight coming through valleys on the side of the moon, turning again into the diamond ring, that bright jewel of sunlight with that sort of ring, ghostly ring around the edge of the moon. And boy, when the sun comes back,
it just blows the image.
Really,
this is when they need to put in the Leon sun back again, I reckon. But it's amazing. Oh, but there it is.
And there it is. And just as we saw, I mean, just that is just the merest sliver of sun, but it is so bright.
Yeah.
It's wow.
Yeah. And back to Leon. Wow, Stefan.
Yeah, we did have. There's many things I would like to do better with recording, but we had these problems in sending and everything. Try to get the exposure right, and also it's really warm, so that had caused problems with both the computers here too. And another thing I didn't think so much about because of all the things doing, my fingers got really sweaty. So kind of I tried to move kind of things on the computer and it didn't move. So there was a bit of extra stress because of these reasons. So it's the warmest eclipse I have been to, and quite a few lessons to learn for sure, especially about the equipment getting hot and not performing as well as we expect, and failing of kind of unexpected reasons and with strange errors, basically.
Yeah, wow. But wow, Stefan, congratulations on that. That was a beautiful totality you caught. And I mean, it has been touch and go recently. I mean, generally Spain has, fairly good weather in terms of clouds in the summer, but Mallorca, it was always a bit of a gamble for you. And in recent days, you have had a lot of clouds near the horizon.
Yeah, I've been watching the weather forecast and also doing the same, basically rehearsing every night or every evening to just kind of see what happens. And the two first nights we had a bit of clouds like today, but still not enough to hide the sun. Then 2 days before today, it wouldn't be great if that was a day of totality. So I'm pretty happy with the weather today. That was really nice. There was a few clouds, but they were not doing anything bad really to the images. Yeah.
Yeah, great. And that's great news for everyone that traveled to Mallorca for the eclipse.
And can I butt in and ask a question about the eclipse, about the telescopes? Because as we were saying, Renata's telescope, the computer says no, mount says no, telescope says no, like we were having lots of issues because it's made for not for solar eclipses. It's a nighttime telescope, so heat can be an issue. But why is the white telescope that, because the image that we're looking at now is a hydrogen alpha telescope. It's specialized on the sun, but why is the white telescope so good for catching the sun during the moment of totality? And I think that it'd be nice to explain that to our viewers.
Yeah, first of all, the hydrogen alpha is filtering so much light. It's not a great telescope for the totality because it blocks so much light, so it's really hard to get anything out. So we need basically a regular camera in a way, and taking the filter off basically gets a kind of regular view. We can see the totality of the eclipse without any glasses or protection. So it is just a regular telescope basically, and that's the good thing for the totality, that we can take the filter off. But it's a bit of how long before do you take the filter off, because you risk damaging if you have it on too long with before and after totality. So there's a lot of things to think about. It's really, really hectic the minutes before and after. And the previous eclipse was quite a few minutes longer, so that made it a bit more relaxing. This time it was like it starts and then they do lots of things and then it ends. Yeah, so it's a very, very busy minutes. Yeah.
Yeah, and we've just top of the screen there. We've just now got a very nice wide-angle view from Palma, looking towards the western horizon. Out over the Mediterranean, and that's a beautiful view you've got there, Stefan.
It's been great. Sorry, but there's been lots of boats anchoring outside this area in a way, and it was very nice to hear people sharing and fluting, and there was so much excitement around us. Basically, we are still a bit far away from them, but we heard them extremely well. So a lot of people were very happy because Palma, this area is basically a bit of a chance. You never know if the clouds would ruin the experience. So I'm very happy that it was turned out the way it was.
Yeah.
Fantastic. And just before you go, I mean, how has it been in Palma generally? You've been telling us about roads being closed and, the authorities really carefully preparing for this eclipse. But there's been quite an upheaval there in Mallorca.
Yeah, we don't know so much because I haven't been traveling because of all these alerts or warnings about traveling today. So basically been shielding here, being just in the local grocery store. That's the only travel today. So I don't know so much really how it's been.
Well, there you go. We have to make sure that we catch the eclipse. We're not out gallivanting when there's eclipse coming up here at time and date. It's important to make sure we get the images to the people. Well, Stefan, thank you so much for taking the time to talk to us, and I'm so happy that we got to see those beautiful images of totality.
That was an amazing replay,
and we're excited for the next one next year. So it's all happening very soon again. We're still going to be going for another 20 minutes here until the sun is going to go down below the horizon. It's looking beautiful and red and quite normal over here in the horizon. So take a look at timeanddate.com. We've got all the resources there for eclipses coming up and other things of how things look in the night sky. There are things happening in the night sky after this that we can talk about in the next segment. So stay here and we will see you soon. you're still watching a total solar eclipse here on timeanddate.com, and the moon's disk is slowly moving off the sun. We're looking at a beautiful sun in front of us as well here, and we can, you know, it's very close to the horizon, so the light is nice and soft, and it's just, yeah. I'm still a bit short of breath after that experience, but yeah, as you can see, our timeline there is coming to an end. Our end of show here will be at 19:30 UTC, so we're just watching the sun set with this beautiful eclipse happening at the same time. So Jeremy still working very hard behind the scenes. He's got his wide feed there, and he's got the telescope feed going, but there are more eclipses to come. So much more eclipses to come. Actually, just in 2 weeks there's an eclipse to come. So on the night of the 27th to 28th of August, so in 2 weeks, there will be an almost total lunar eclipse. You can see it in North and South America and Europe just before sunrise, and we will be streaming it live on timeanddate.com. Stefan is picking up his telescope, and he is going to Lisbon, Portugal to live stream that. So it's all happening still. So the almost total lunar eclipse is a lunar eclipse where the moon will turn red. It's a very deep partial eclipse, so we're pretty excited about that one too. But there's another total solar eclipse next year, also here in Spain, a bit further south in the southern part, a bit earlier, August 2nd, and it can be seen in the southern part of Spain, in northern Africa, and the Middle East. This is the famous one that's going to have a really long totality, especially in Egypt, up to 7.5 minutes. Am I remembering that?
6.5 minutes.
6.5 minutes. So yeah, it's coming up very soon. So that is very exciting. There's a little bit of cloud coming over Jeremy's projection there of the sun. So yeah, we're still got lots of work to do, Graham.
Oh, we do. Actually, that's a lovely image there of the moon nibbling away at one side of the sun, and a little tiny cloud nibbling away at the other side of the sun there. Anna, we have to say a very big thank you to all of our collaborators around the Northern Hemisphere who have been bringing us some wonderful pictures of this eclipse. In Kristiansand in southern Norway, we saw a beautiful crescent sun. Those pictures were from the Agder Astronomy Society. We saw some great pictures from London. Those were from our good friends at the Royal Observatory Greenwich. Thank you for sharing those with us. We also saw an amazing crescent sun from Kassel in central Germany. That was the team celebrating the first day of operation of the new Kassel Observatory there in central Germany. In Genoa, in northern Italy, our friends at the Righi Observatory and Primo Canale, who were on the Terrazza Colombo at the top of a skyscraper in downtown Genoa, enjoying this eclipse. And over in North America, at St. John in Canada, our good friend Chris Kerwin from Astronomy by the Bay, some great pictures from there. Chris will also be sending us some images of the lunar eclipse in a couple of weeks' time. As always, of course, there are issues with weather. And of course, there's all kinds of issues that we have to contend with when we're streaming eclipses. In Reykjavik, Iceland, we had Sævar Helgi Bragason. He was all lined up to bring us images of totality from Iceland, but unfortunately, clouds prevented anything from happening there. Also struggling with the gremlins today in Oldenburg in northern Germany. The team at the University Observatory of Oldenburg, unfortunately, we didn't see anything from them today. And in New York, in the US, there was a small partial eclipse at lunchtime there. Kat Trosch at the Astro Society was observing that from on the ground in New York. We should also mention up at the very top of Norway in Tromsø, Anders Olsen had his equipment out, but again was really unable to capture anything because of the clouds
and rain.
The clouds and rain,
yeah,
as well, which is never good for telescopes and equipment and that kind of thing. So thank you very much to everybody who's been sharing their images of the eclipse today.
But we did get some beautiful images from here as well, from Leon in Spain, our team with Renata Melanhus and Jeremy Krause. They really worked their little bums off to get us some beautiful telescope images. Don't think Renata hasn't been working hard, because she has been trying to figure out those camera issues for days. It's also Stefan Thorsen in Palma de Mallorca in Spain. We just talked to him. He did great. Thank you, Stefan. In Stavanger, Norway, Ada Opperhau. She was out with our little smart camera, our little smart telescope, and got beautiful images from Stavanger, Norway. She's, hometown. It's almost like I wish I was there. And let's not forget all the wonderful people back at HQ in Stavanger. Arjen Rex, Daniel Leland, Andy Ardner, Jason Lydia, Sarah Kornberg, Ellie Elliott, and Anya Smith. Now you can see that the sun is looking a bit weird on that telescope image. You can see on that widescreen image that the sun is setting. It really is setting. So we're going to leave you with this beautiful sky, but there's always something else happening in the night sky. And tonight, there's an after party.
There is an after party, really for anyone in the Northern Hemisphere. By coincidence, tonight is the peak night of the Perseid meteor shower. This is the Northern Hemisphere's big annual meteor shower. It's where we can expect a pretty good stream of shooting stars in the night sky. Every year, this meteor shower peaks around the night of August 12th, August 13th. And just by coincidence, the peak of the meteor shower is tonight. So wherever you are in the Northern Hemisphere, if you have clear skies, then tonight is an excellent chance to get out and enjoy the eclipse after party, which is the shooting stars of the Perseid meteor shower.
Just lie down on the ground, look up, and there will be up to 100 shooting stars per hour. So it really is a good chance to see another one of nature's huge spectacles. So that's it for us. We're going to leave you with the sunset, but we're going to be back in 2 weeks' time. We've got the sun. We're looking at the sun going down behind the mountains in the horizon. So we're ready to say bye-bye to everyone there, and we will see you back here in 2 weeks. Bye.